Those are Raspberry Pi Zeros, but with those connectors and everything, they're quite small, but you need all the rest to even get them to work. And without this, you can't even connect Ethernet or a hard drive. So this is what I came up with then. There is a space for a hard drive to go in there, and there is space for the Raspberry Pi to be mounted, like this. And it all gets connected through those pogo pins. And in this video I'm going to show you how I build it. But before I could do anything productive, I needed a coffee. First I needed a plan what I actually wanted to do. Pi 0 connected over USB to the RJ45, the two USB ports, and then of course we have the USB to SATA bridge. And here as well is the USB-C in, and of course from the USB-C input plenty of LDOs for 3.3 volts and 1.1 volts, and also to the bridge. After I was done designing the whole PCB in Altium, I tried it to print it, but I assumed my printer could be too small. It didn't even work. This time I have the bigger printer here, and as you can see, I filled it with a copper sheet, so this should work. Let's see. Yeah, this is how it should look like. This is way better. After I had it ready, I made a holder with other PCBs to align it on the same height for the stencil and solder paste application, and that's what I did here. Yes, it's not perfect, at least on this side, and I overspilled a bit, but it shouldn't matter because I'm using this solder paste. I have no clue what the brand is, and it's expired, but whatever. But this goes together super nicely actually. Next step was to place all the parts manually, but I didn't film it, and see you in a second when everything gets into the oven. This is what it looks like after it came out of the reflow oven with an infrared light and a custom 8-minute profile, and the last step was to manually solder all the through-hole connectors. That's what I did here. This is what the final product looks like. I marked it because I built more than one, and you can see all the LEDs light up. No red LEDs lighting up, because this would indicate a fault. Some solder bridges on the M2 connector are still there, but they don't matter because they're on the same plane. After the hardware was done, I followed the quick tutorial from Pi My Life Up and made a Samba share on the Raspberry Pi Zero. And then I connected to it using my Windows machine. I figured out the IP over the router, and then it is time to test. I first copied a file from the current project from the beginning that you can see, but it was way too small and super quickly done. So I tried it again with a video file from the coilgun video I did a few weeks ago, which is roughly 1 GB, and it took a lot of time to calculate before, but then it started to work with roughly a little below 10 megabyte per second, and this was due to the USB 2.0 constraints of the Raspberry Pi Zero, and also the processing power. The Raspberry Pi Zero second generation worked a bit better with roughly 10 to 11 megabyte per second. And here you can see the NAS itself with the network connection. This is the 150 address, the Raspberry Pi, the SD card for the Raspberry Pi OS, the hard drive where I'm copying to, from time to time, the hard drive activity LED blinking. But what are actually use cases? So I came up with a few stuff. First of all, I can use it as a MacBook time machine backup, which draws super little power, works with a LAN adapter, so no need for the slow Wi-Fi, and it doesn't matter how fast it is for the MacBook to update. The second one is if I add a camera over here, I can use it as a security cam with added storage. With 250 GB of SSD, it can film for a bit of time and all gets processed over the Raspberry Pi. It doesn't take a lot of power. Another use case is RetroPie, where the hard drive can store a lot of footage and of course other home NAS applications. This is what I designed it for. In a future video I'm going to add power over Ethernet, so you don't need the USB at all and it can just be connected via the Ethernet port and also get powered over there, and maybe adding another camera connector or something, or a 3D printed housing, so that I can use it as a surveillance camera with just the Ethernet connection needed. That's basically it. Thank you for watching. I hope you found it a bit inspiring. This is a bit more difficult project, at least from the electrical side than I normally do. But yeah, I wanted to challenge myself. Leave a like, subscribe and comment if you want further information, and thank you for watching.